So for number 74, we want to determine whether the sequence is increasing, decreasing, or not monotonic. So not monotonic means that it alternates between increasing and decreasing. So an is equal to 2n minus 3 over 3n plus 4. Okay. And what we're going to do here is we're going to compare it to the function y is equal to 2x minus 3 over 3x plus 4. And the reason that we can compare it with a function is because the function behaves the exact same way as the sequence, except that the function is defined for all reals and the sequence is only defined for the naturals. So if I have a random function here, function f of x, and I have a function a of n, and these have the same formula, we can see that they're going to behave the same way, except that a of n is going to be just dots, whereas f of x is going to be continuous, right? But if f of x is increasing, so is a of n. If f of x is decreasing, so is a of n, and so on and so forth. And so we're going to use this function here, and what we're going to do is we're going to take the derivative, because the derivative tells us about the growth, right? So if the derivative is positive, it means that the function is increasing, and so is the sequence. If the derivative is negative, it means that the function is decreasing, and so on. So we're going to take y prime, and that is going to be the bottom one squared, and then we're going to have the lower function times the derivative of the upper, which is 2, and then minus the upper function times the derivative of the upper, which is 3. So this is going to give us, on the bottom, we still have 3x plus 4 squared. And then on the top, we're going to have, let's see, 3x times 2, so 6x. 4x times 2 is plus 8. And then minus 2x times 3, so minus 6x, and then minus 3 times 3, so minus plus 9. And so this is going to give us 6x minus 6x cancels out, that is 17 over 3x plus 4 squared. So once we do this, we can see that the derivative is always positive, because 17 is always positive and the denominator is always positive as well, right? Because it is squared. There's no way that we could get a negative thing on the bottom, because even if we plug in, for example, minus 10 for x, right, we would have minus 30 plus 4 and then squared, that's going to be positive. So we can say here that y prime is always positive, so y is increasing, and therefore an is increasing. Okay, so we have shown that an is always increasing. Now it wants us to see if the sequence over here is bounded, right? Well, if it is always increasing, it means that the smallest term is the first one, because the second is going to be bigger than the first, the third is going to be bigger than the second, and so on. So the smallest term possible is going to be, let's evaluate it for a1, is going to be equal to 2 times 1, so 2 minus 3, divided by 3 times 1, so 3 plus 4, and this is going to be minus 1 over 7. So we can see here that minus 1 over 7 is less than or equal to an, so that's the lower bound, right? But what about the upper bound? Well, the upper bound is going to be, actually, and let me put this here. So minus 1 over 7 is smaller than or equal to an, and the upper bound, we're going to have to take the limit, right? So we're going to take the limit as n approaches infinity of 2n minus 3 divided by 3n plus 4. And so we're taking the limit to see how it behaves as n grows bigger and bigger, right? So what's going to be the upper bound here? And so when we evaluate this, we get 2 times infinity over infinity. That doesn't really help us, so we're going to divide the top and the bottom by n so that we can at least get some quotients, and that's going to make it nice for us. So 2 divided by n is 2 minus 3 over n divided by 3 divided by n is 3 plus 4 over n. And so when we take this limit here, we're going to get 2 minus 3 divided by infinity is 0, so that's going to be 2 minus 0 is just 2. And then 3 plus 4 divided by infinity is 3 plus 0, so that is going to be equal to 3, right? And so we can see here that at most, an is going to be 2/3. So we see here that an is always increasing, and it is bounded between -1/7 and 2/3. So an is bounded. And that is it for number 74.